Hello everyone. Today we are going to discuss about some data visualization techniques used in data science. To understand data visualization, we have to understand what is data. Data is a collection of facts such as numbers, words, observations, measurements, or even just descriptions. Data itself has no meaning and it can be anything. Data can be divided into two types, qualitative data and quantitative data. Imagine a classroom of 20 boys and 20 students, where the number 20 represents quantitative data and the words boys and girls represent qualitative data. Quantitative data is numerical data, and qualitative data is description of the given data set. We can use the given data to generate information. We can use the data to find out the total number of students in the classroom, which is 40. In this case, 40 can be considered as an information. Quantitative data can be described in two ways. They are discrete data and continuous data. In the previous example, the number 20 is a discrete data. Discrete data means countable data, and each of the students may have different heights. That can be considered as continuous data. Continuous data means measurements. Graphs. Graphs are used to represent the relation between two or more datasets in an easily understandable way. Graphs are pictorial representations for one or more sets of information and how those informations are related to each other. There are many types of graphs and charts of various complexity. Some of them are bar graph, histogram, line graph, pie chart, and scatter plots. Let's begin with the bar graph. A bar graph is a graphical display of data using bars of different heights. A bar graph can be horizontal or vertical. Each axis is labeled with either a categorical or numerical variable. The bars' heights are scaled according to their values, and the bars can be compared to each other. The bar graph is also known as bar chart and Pareto diagram. Let's imagine if you just did a survey of your friends to find out which kind of movie they like. Instead of representing the collected data in a numerical format, we can represent the data using a bar graph. Using this bar graph, we can easily understand that most of the students like romantic movies and only one person liked drama. Bar graphs are good when your data is in categories, but when you have continuous data, you should be using a histogram. For example, if you have to represent the height of students in a classroom, you should be using a histogram rather than a bar graph. In this kind of graph that also uses bars, ranges of values are listed at the bottom and these are called classes. Taller bar represents the classes with greater frequencies. In the given example of the histogram, we can easily understand more people are from the frequencies between 250 and 300. A bar graph represents the difference between categorical data, where a histogram represents the frequency of a given class. A graph that shows information that is connected in some way is called line graph. Let's take the given example. Imagine a graph that shows the growth of the market value of a company throughout the years. As you can see, the given graph shows the analytical growth of the company in between 5 years. In 2000, the given company owns 0.01% of market value, and within 20 years, the company has grown to 50% of the market value. and in between 2010 and 2015, the market value was slightly decreased. Rather than representing the data in a numerical format, the line graph makes it easy to understand and can analyze the growth of the company within one look. Comparing various sets of data can be complicated, but line graphs make it easy. The plotted peaks and dips on the grid allows you to monitor and compare improvement and decline. Pie chart. A special chart that uses pie slices to show the relative size of data. Let's take the previous example of the survey to find out the favorite genre of movies. In this pie chart, we can see that the romantic movies have a lead than other genres of movies. To draw a pie chart, we have to convert the collected data into percentage. After finding out the percentage, you have to convert the data into degrees. A full circle has 360 degrees, so we do this circulation. The given equation can be used to convert the percentage into degrees. Scatter plots. A scatter plot has points that shows the relationship between two sets of data. It displays paired data using the vertical y-axis and horizontal x-axis. Let's take another example on this situation. A local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are figures for the last 12 days, but we will be showing the data for 8 days. It is now easy to see that warmer weather leads to more sales. When the temperature was at its lowest, which means when it was 11.9 degrees Celsius, the total ice cream sale was of only $185. And when the temperature increased to 22.1 degrees Celsius, the ice cream sale increased along with it to $522. To generate all these graphs, we can use Microsoft Word, which can give you an easy idea of how it works. But to analyze bigger data sets, which could be containing millions of data, it would be hard for us to do all these graphs in Microsoft Word. There are so many other tools which were specifically designed for data analytics and representation. Hope you learned something new. Thank you.